In this video, we're going to be looking at the equations of a line of best fit and the types of questions you can get in a GCSE paper. So here we have a situation where we have students' GCSE maths marks and their A-level maths marks on a scatter graph. And in the question, we're given the mean GCSE maths mark and the mean A-level maths mark, as well as the gradient, which is 0.7. Now, the first task we are being given in the question is to draw a line of best fit on the graph using the data that we've been given. So firstly, we've been given the mean point. So let's start writing the information that we know. So the mean point is x bar, y bar, and that is going to be equal to 578 and 78. And the gradient m is equal to 0.7. So, with this information, we have to draw a line of best fit. Now, we can't simply plot the mean point and draw a random line through it. We actually have to work out the angle with which we have to draw a line of best fit with this information. So, firstly, let's plot our mean point on the graph. So it's 578, 78. 578 is right here. We're going up in units of 1. And 78 is right here. I think I've marked that wrong. Let me just double check. That's 1 over. 1 over. There. Main point should be here. So their main point is plotted, and now we have to work out how we can draw the right angle for our line of best fit. Well, firstly, what we do is we can work out what C is, because we've got a value for x here, a value for y, and the value of the gradient. So we're going to write out our equation of a line of best fit, which is y equals mx plus c. Now, y in this case is 78, m is equal to 0.7, and x is equal to 578. So 0.7 multiplied by 578 plus c finishes off our equation. We can now rearrange this to work out what c is. So 0.7 multiplied by 578 is equal to 404.6. So 78 is equal to 404.6 plus c. And if we want to get c on its own, all we have to do is take away 404.6 from both sides of this equation. So 78 take away 404.6 is going to be equal to negative 326.6. So c is equal to negative 326.6. And now we have an equation of a line of best fit. We have y equals m, which we know from the question is 0.7, x minus 326.6, where 0.7 is m and negative 326.6 is c. Now that we have the equation of a line of best fit, what we can do is we can plot 2 points and draw a line through them. So what I would suggest is pick an extreme value for x, that being the most left value for x and the most right value for x, and substitute it into this equation here. So the most left-hand value for x is 540, so x equals 540. All we're doing is substituting it into this equation, so y is going to be equal to 0.7 multiplied by 540 minus 326.6. Get my calculator back out. So 0.7 multiplied by 540 minus 326.6. And that's going to be 51.4. So my first point is 540. 51.4. Move that slightly over so you can see. And then my second example for x will be the right-hand extreme, which is 600. So let's do an x equals 600. Y is equal to 0.7 multiplied by 600 minus 326.6. 6.6. So 0.7 multiplied by 600 minus 326.6 is 93.4. So my second point will be 693.4. So now I'm going to plot those 2 points. You can just do a try and be as accurate as possibly can be. I'm not expecting it to be super precise. We've got 540 for x and 51.4 for y. Well, here's 51, so it's going to be between 51 and 52, so it'll be here. And then the second point is 693.4. So there's 600, go up to 90, and 90, it goes up in units of 1, so 91, 92, 93. 93.4 would be around here. Now that we've got our 2 points on the graph, and I'm just going to make them slightly bigger because the printing out isn't great for this. There they are there. I'm going to try and draw my straight line through those 2 points and also passing through the main point. So let's try that as effectively as we can. Up to the main point, through the main point. There we go. That should be our line of best fits. So it goes through 2 points that we've calculated here, the 540, 51.4 and the 693.4, and it should also pass through the main point as well. Now, the second step of this question is interpreting the gradient. Now, we've done that recently in class. So we know from the question, though, that the gradient is 0.7. So gradient is 0.7. And to interpret this, we have to say, using our sentence stems, as the x variable increases by 1 unit, the y variable will increase by the gradient. So I'm going to write that out first. This isn't the answer. This is the generic sentence stem for interpreting gradient. As the x variable increases by 1 unit, the y variable increases by the gradient. So that's the generic interpretation of a gradient. However, we have to use it in context here. We've been given context in the question. That is, we're measuring GCSE maths marks versus A-level maths marks for a sample size of students. So we have to use those named variables in our answer. So we would say, as the x variable, which is GCSE maths marks, as a GCSE maths mark increases by 1, the A level, the y variable, maths mark increases by the gradient, which is 0.7. All right, so there's a full question of being able to plot your main point, draw your line of best fit by using substitution, where you have picked the extreme values of x in the particular graph and substitute it back in to get your values of y. And you can plot those 2 points on there and making sure the line goes through all 3 points, through the first point, through the main point, through the second point that we've used substitution for. And then finally, when we're interpreting, we're using our sentence stem. As the x variable increases by 1 unit, the y variable increases by the gradient. So in this case, as the GCSE maths mark increases by 1, the A-level maths mark increases by the gradient, which is 0.7. So that's one type of question you could get asked. Here's another one, which is quite similar. So it says, the scatter diagram shows the length of a spring when different weights are hung from it. The equation of the line of best fit is y equals 5x plus 50. Draw this line on the scatter diagram. So again, we haven't been given a main point this time, but we can still use the method I just previously shown you. So let's pick 2 extreme examples for the x-axis. So we've got 0 and we've got 5. So we're just going to substitute 0 and 5 into this equation of a line of best fit here. So when x equals 0, y equals 5 times 0 plus 50. So 5 times 0 is 0 plus 50 is equal to 50. So our first point is 0, 50. I'm going to plot that point here. 0, 50 is right here. And the second point, let's choose another extreme example. So here's 5. So when x equals 5, y is equal to 5 times 5 plus 50. Again, all I'm doing is substituting 5 into this equation here. So 5 times 5 is 25 plus 50 is equal to 75. So my second point is 575. And let's plot that on the graph. 5 and 75 are going up in units of 2, 4, 6, 8. Yep, we're up in units of 2. So there's 70. 5 is here. 70 is here. 72, 74. It's actually marked, is it? Let me grab my ruler just to double check. So that's 70 there. 72, 74, 75 would be here. 75 is literally underneath that other point that's been plotted. So now we have to draw our line of best fit through those 2 points. And there we go. Done. The line of best fit was found by substituting the 2 extreme values of x in the graph into the line of best fit, the equation of the line of best fit to find the values of y for both, and then you plotted the 2 points, 0, 50 and 575, and made sure you drew a straight line through both points to the edge of the graph. So those are 2 examples of equations of a line of best fit achieved by using substitution.